Friends, this is the walkthrough video for 2 days worth. Isn't that exciting? As you might be aware, I'm out today. Can you tell me one more time what chi-squared analysis does? You'll be happy that we did all this, I promise. Don't look back if you can help it. What's chi-squared analysis help us do? What's it tell us? All right, so today we're going to think about predicting the outcomes of genetic crosses. You can just write this on Thursday. You can write same for Friday. As you learned from doing yesterday's pedigree problem, Mendelian genetics is often used in science and medicine. So today we're going to do something that helps us think about Punnett squares and how they get applied in real life biology that isn't just about medicine like pedigrees we learned about yesterday. So the assignment is a HHMI biointeractive one. It's called Using Genetic Crosses to Analyze a Stickleback Trait. Before we do that, I wanted to say that I know that several of you want to do test corrections. Multiple choice test corrections open in SRT the day that I get back. You just need to ask me for a pass on Monday. I'll make sure I write one for you. Um, in week 6, we are going to be working on finishing project 3 and starting project 4. We just had our meeting today about it. I'm really excited. It's going to be really cool. We'll celebrate the conclusion of March Mammal Madness next week. We got a lot of good stuff going on. So, um, I work that first model organism for genetics really is the mighty stickleback. This is a tiny fish with some big powers. Before we think about this, I wanted to show you some generation words. So you can think about this as the grandparents, the kids, and the grandkids. You can think about this as kids, the parents of those kids, the grandparents of those kids. So those ideas, this one stands for parental. This is filial, 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 which is a word that means sibling. And then this idea about how to express genotypic and phenotypic ratios. If it's been a while, oh, cool. If it's been a while, like let's say that you made one of those Punnett squares yesterday and it was like 50% and 50%, you would write 1, 1 if it's a phenotypic ratio of that. In those like 3-to-1 examples where 3/4 of them are dominant and 1/4 of them is a recessive phenotype, in those chance probability maps, like the eyeball one we saw yesterday, it would be a 3-to-1 phenotypic ratio. It'd be a 1 to 2 to 1. It's aligned in the same order as Hardy-Weinberg. So homozygous dominant, heterozygous, homozygous recessive. So cool. Now that you know those things, you are ready to look at these fish cards. The first thing you're going to do when you come through here is you're going to click into the pedigree assignment. And this is the teacher view, but you'll get the idea. This is the pedigree assignment. This one, using genetic crosses. This is the tab I want. Cheers. So you're going to find that it's going to open this up for you, and I'll put the fish cards there too. You're going to start by reading introduction. I took many classes. I took 3 separate classes from David Kingsley. He is a nice guy, and he's going to bicycle into the lab where I used to work, which is so exciting. Um, the first thing you're going to do is watch a short film. That short film is listed in the assignment detail that you're going to see here in a moment, just as soon as I list it. And you will be able to watch the movie and see the cards. So just make sure that you're following those pretty intently. And here's an explanation for the pelvic spines in case you get stuck and you want to see it in color. You're going to do this assignment in your lab notebook. You've got Thursday and Friday to do it. You can search for the answer key, but you want to use it as a tutor. And then remember, we are calculating chi-squared differently than may be presented here. So just go back at the notes we've used throughout the years. We're thinking about that. Follow the instructions on the slide. You're great. I'm looking forward to seeing you again on Monday. That's it. Take care out there.